Welcome to the Explainer. Today, we're cracking open the hood to see how a blockchain really works. We're going to get right into the nuts and bolts, the blocks, the crazy math, and the transactions that make this whole thing tick.
All right, let's start with something we all know, sending money. With your bank, everything is centralized. The bank's in charge, they keep the records private, and yeah, they can reverse the transaction. But with blockchain, it's a totally different ballgame. It's a network of equals, transactions are pretty much set in stone, and the record book is open for everyone to see.
And that difference right there leads to the big fundamental question that blockchain was built to answer. I mean, if there's no bank, no one in charge, how on earth do you stop people from cheating the system?
This is what's known as the double spend problem, and it's a huge hurdle that's pretty much unique to digital money. It's really the core challenge, right? How do you build trust between strangers on the internet when you're dealing with value? Just think about it for a second. Any digital file, a photo, a song, a document, can be copied perfectly a million times over. It's just data. So if your money is just data, what's stopping me from making a copy of my digital dollar and sending it to you? And then also sending that exact same dollar to someone else? If that could happen, the whole system would collapse.
So to fix this, the system needs an absolutely foolproof way to track every single coin and verify every transaction. The best way to understand it is to just follow the journey of one transaction and see how it works.
Okay, so it all kicks off with your digital wallet. Now this isn't something you put in your pocket. It's actually a pair of powerful related cryptographic keys. You've got your public key, which works just like your bank account number. Feel free to share that one with anyone who wants to send you crypto. But then you have your private key. This is the big one. It's like your ATM pin, and you guard it with your life, because it's the only thing that proves you own your funds and lets you spend them.
So, let's say you want to send some crypto. Your wallet software creates a message with all the details. Then, it uses your secret private key to create a unique digital signature for that one transaction. Think of it like a wax seal that nobody can forge. It proves you, and only you, approved this payment. Once it's signed, that transaction gets broadcast out to the whole network for everyone to see.
And here's where it gets really cool. Your transaction doesn't just instantly appear in the other person's wallet. Nope. Instead, it gets scooped up with a bunch of other recent transactions and put into a waiting list, a list that's about to be permanently sealed inside something called a block.
To make these blocks super secure and basically tamper-proof, the network uses this amazing mathematical tool called a hash function. The best way to think of a hash is as a unique digital fingerprint. You can feed it any data in the world, a word, a book, a whole list of transactions, and it will spit out a unique fingerprint of a fixed size.
Let's see this in action. We'll take this simple sentence right here as our input.
And boom, the hash function runs it and spits out this long, one-of-a-kind string of characters. That is its unique digital fingerprint. Now, the magic, the really critical part, is what happens when you make the tiniest little change.
See that? We're just adding a single exclamation point at the end. That's it. A tiny little tweak.
And bam! Look at that. A completely different, totally unrecognizable hash. This is called the avalanche effect, and it's what makes the blockchain so incredibly secure. If a hacker tried to change even one comma in an old transaction, the hash would change completely, and the entire network would immediately know something was wrong.
So how does a block get finalized? This is where people called miners jump in. It's a race. They're all competing to solve a really hard puzzle. Why? Because the winner gets a reward in brand new crypto. This is literally how new coins are created. They take all the new transactions, they add the fingerprint of the last block, and then they start guessing a random number called a nonce. They combine all that data, hash it, and check if the result is special. Like, does it start with a whole bunch of zeros? If not, they guess a new nonce and try again and again and again, millions of times a second.
Now, this puzzle is meant to be hard. It takes a ton of computing power. The whole system is actually designed so that, on average, it takes about 10 minutes for some miner somewhere on the planet to get lucky and find that winning number. It's hard to find, but once you find it, it's super easy for everyone else to check your work and say, yep, that's the right answer.
So, a miner solves the puzzle, they found the golden ticket. What's next? Well, this is how that unbreakable chain actually gets built, link by link. The miner who won the race gets to add their new, verified block of transactions to the official history book.
So let's look inside that block for a second. You've got the transactions, you've got a timestamp, and you've got that winning lottery number, the nonce. But the single most important piece of information in there is the hash, that digital fingerprint of the block that came right before it.
This is literally the chain in blockchain. Each new block points back to the one before it, creating a cryptographic chain that goes all the way back to the very first block ever created. So here's the kicker. If some bad actor tried to go back and change a transaction in an old block, its digital fingerprint, its hash, would completely change.
And that new hash would no longer match the hash that's recorded in the next block. The chain would instantly break. That block and every single block after it would become invalid. To pull off a heist, you'd have to redo all that incredibly hard mining work for every single following block, and you'd have to do it faster than the entire global network combined. It's pretty much impossible, and that's what makes the history permanent.
And for the final step, once a new block is verified and chained up, it's broadcast to the entire network, and every single participant adds this new block to their own copy of the history.
This is the last brilliant piece of the puzzle, the distributed ledger. Because everyone on the network has an identical, up-to-the-minute copy of the same exact chain, the whole community can agree on what's true. There's no single weak point. You don't need a bank to be the source of truth, because the network is the source of truth.
And that brings us right back to where we started. This entire incredible system, the keys, the hashes, the mining, the chains, it was all designed from the ground up to solve that one core problem. How do you stop people from spending the same digital money twice without a middleman?
Which really leaves us with one final huge question. If we've built a trust machine, a way for total strangers to agree on things and exchange value securely, what else can we build with it? What other parts of our world, from voting to supply chains, could this technology completely change? Thanks for watching.